Just 20 light-years away, a newly confirmed exoplanet has scientists buzzing with excitement. HD 20794d, a super-Earth orbiting a Sun-like star, lies within its star's habitable zone, raising the possibility that it could harbor liquid water, one of the key ingredients for life. In this video, we'll break down everything you need to know about this thrilling discovery, including how it was confirmed, what we currently understand about the planet, and what it means for the future of space exploration. The story of HD 20794d began in 2022 when Dr. Michael Creanier from the University of Oxford detected an unusual signal while analyzing archived data from the HARPS, High-Accuracy Radial Velocity Planet Searcher, spectrograph at the La Silla Observatory in Chile. The signal suggested the presence of an exoplanet, but the evidence was weak, close to the detection limit of the instrument. Scientists had to determine whether it was truly caused by an orbiting planet, activity from the star itself, or even an instrumental error. Rather than dismissing the signal, an international team of researchers took on the challenge of confirming its existence. They analyzed more than 2 decades of precise measurements from HARPS and Espresso, another powerful spectrograph in Chile. These instruments detect tiny variations in a star's light spectrum caused by the gravitational pull of orbiting planets. However, confirming the planet's existence was no easy feat. Scientists had to filter out noise, remove potential distortions from the instruments, and rule out false positives. After years of advanced data analysis, they finally verified that HD 20794d is real. So what makes this planet so intriguing? First, its location is significant. Orbiting a G-type star, similar to our Sun, in the constellation Eridanus, it sits just 20 light-years from Earth. That's relatively close in astronomical terms, meaning future space telescopes could study it in greater detail. One of the most exciting aspects of HD 20794d is its position within the habitable zone, the region where temperatures could allow for liquid water. However, there's a major challenge. Its orbit is highly elliptical rather than stable and circular like Earth's. This means the planet moves closer to its star at some points and farther away at others, leading to dramatic climate fluctuations. During its closest approach, it might experience extreme heat, possibly causing water to evaporate. When it drifts farther away, it could become too cold, freezing any liquid water. The presence of a thick atmosphere could help regulate these temperature swings, but without direct observations, its true habitability remains uncertain. In terms of size and composition, HD 20794d is classified as a super-Earth, with about 6 times Earth's mass. However, astronomers are still unsure whether it has a solid, rocky surface or if it's more like a mini-Neptune with a thick, gaseous atmosphere. If it has a stable, rocky surface and a balanced atmosphere, it could have conditions similar to Earth. On the other hand, if it contains high levels of hydrogen and helium, it may be more like Neptune, making it far less hospitable to life. Future telescopes will analyze its atmosphere to search for biosignatures, chemical markers such as oxygen, methane, or carbon dioxide. The detection of such signs could mark one of the most groundbreaking discoveries in human history. Despite its potential, HD 20794d presents challenges for habitability. Its eccentric orbit could lead to extreme temperature shifts, making it difficult to sustain stable conditions for life. However, if it has a dense atmosphere or a strong greenhouse effect, it may be able to regulate its climate and retain liquid water. Another key factor is geological activity. On Earth, volcanic activity and a dynamic interior help regulate climate and support life. If HD 20794d is geologically active, it could replenish its atmosphere and maintain a stable environment. Conversely, if it lacks a protective magnetic field, its atmosphere may gradually erode over time, reducing its ability to sustain life. Ultimately, the discovery of HD 20794d adds another promising candidate to the growing list of potentially habitable exoplanets. While many questions remain, upcoming space missions and telescopes could provide the answers we need to determine whether this distant world could truly support life. Stellar winds may significantly reduce a planet's habitability, but beyond this challenge, several exoplanets have captured scientists' interest due to their potential to support life. Proxima Centauri b, located just 4.2 light-years away, is the closest known exoplanet within a habitable zone. However, its proximity to a red dwarf star exposes it to intense radiation, which could strip away its atmosphere. Another intriguing system is TRAPPIST-1, about 40 light-years away, home to 7 Earth-sized planets. Of these, TRAPPIST-1e, 1f, and 1g orbit within the habitable zone. However, these worlds are tidally locked, meaning one side experiences perpetual daylight while the other remains in darkness. A stable atmosphere could potentially balance temperatures, making these planets more hospitable. Kepler 442b, approximately 1,200 light-years away, stands out as one of the most Earth-like exoplanets discovered. It receives around 70% of the sunlight Earth does, suggesting conditions that may allow liquid water to exist. Similarly, Doi 700d, a rocky exoplanet 100 light-years away, orbits in its star's habitable zone. Unlike many M-dwarf stars, its host emits fewer solar flares, increasing the likelihood that it retains an atmosphere. While these planets show promise, the next challenge is determining whether they actually harbor life. Future telescopes such as NASA's Habitable Worlds Observatory, the Extremely Large Telescope (ELT), and the LIFE mission will analyze exoplanet atmospheres for biosignatures like oxygen, methane, carbon dioxide, and water vapor. Detecting these gases in the right proportions could indicate biological activity. Additionally, interstellar probes may revolutionize exoplanet research. Projects like Breakthrough Starshot aim to send light-powered spacecraft to explore planets such as Proxima Centauri b. If successful, similar missions could target other distant worlds like HD 20794d, allowing us to study them more closely. Ultimately, the discovery of HD 20794d raises one of the biggest questions. Are we alone in the universe? With billions of stars and planets, it seems increasingly likely that habitable worlds are common. The true challenge lies in detecting them and confirming the existence of life beyond Earth. Thank you for watching. Stay curious and keep looking up. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating content about space, science, and the mysteries of the universe. Hit the notification bell so you never miss an update on the latest discoveries. Let us know in the comments. Which exoplanet do you think has the best chance of hosting life? We'd love to hear your thoughts.